My talk today is about a small project that I've been carrying on for a couple of months since now. It's a project about a door opening system that I have developed with some friends in the coworking. I am now I have a table in a coworking, and we have developed this project together. Um, a brief mention of what kind of developer I am. Like mentioned before, I belong more to the 1, 2, 3 years of experience layer of Rust developers. I'm not very experienced, and this was the first project that I took from start to finish or to production. The theme of the conference is Rust in production, so I thought it would be an interesting thing to show, although not the most complicated project you will find. I also this year I would like to underline that I'm lucky enough as a freelance backend developer. I also this year I will start working on Rust projects, so my idea is to put in production Rust as a platform. Wish me luck. So, what this project is about? Like I mentioned before, I work in Germany as a freelance developer. I have a table in a coworking, and last year at the last Rust Fest, during the networking workshop with a friend of mine that he is in London, we started looking at the web framework ecosystem in Rust because we wanted to see how mature and how usable was from the perspective of a backend developer. And since then, I kept on working on this backend. And when I moved to Germany, to this coworking, this friend of mine that managed the coworking told me, look, I would like to automate the entrance to the coworking because, you know, I don't have time to get to the doorbell every time someone ring the bell. So I would like to automate this thing. And I told him, look, by chance, I had something that might interested you. And I showed him a little bit what I've done, and we decided to go on with the project that I had already started. Let's see the main components of the whole project. Basically, there is a small Arduino device connected to the door opener, and which is coded with just a simple C code, nothing special here. Then there is a Raspberry Pi, which hosts the backend that is exposed on internet. And an important detail is that this is an old model of a Raspberry Pi that I had around, and we will see later why this detail is important. And finally, we have the mobile application that we give to all coworkers that have a table in this coworking, because we want them to be able to enter when they want during the night, weekends, and so on. And for this task, I chose, since I am a backend developer, I choose something very easy to get things done very quickly. And I thought that I would try the Flutter framework. It's written in a Dart language. It's something from Google. Looks interesting. It's a JavaScript-ish language, so it's pretty much easy to get started and hack together a working prototype. This is the photos is a little bit stretched, but this is the first prototype of the Arduino that we have implemented. It's basically a breadboard for those that do a little bit of embedded. It's just a breadboard where you put all the components in and you experiment and you see if it works, and then if everything works, then you eventually maybe print your circuit board. Here it is, the circuit board that we have wrote using some IDE specialized. They printed the board. They sent us to they sent them to our coworking. We have soldered all the components, resistors, relay, and the node MCU that we'll see in detail later. It was really fun working with this because this is something that you work on and you can touch. You really see what's happening, and so I recommend everyone to play a little bit with simple embedded systems. And this is the final prototype. You can see on the edge of the board there's the node MCU, which is a small circuit that has it's pretty much evolved. It has a wireless module. It can be programmed using a USB connection or a simple serial connection, and basically it connects to the local network, and the Raspberry Pi talks to this device and authenticates the client that has requested the door to be opened. If the authentication between the backend and the Arduino succeed, then there is a small switch and the door is opened and the person can get into the coworking. So quickly mention to the front end, like I mentioned, it's a simple web application using Flutter. It's a really very easy, very simple thing. I didn't want to delve too much into the mobile development, so it's basically just one screenshot that opens the door after the login. Still, there is a couple of rough edges because we are working with a network framework and it needs to manage better errors. For example, this weekend, unfortunately, the internet connection completely failed in the whole area where the coworking is, so I could not prepare a demo. So I will just have some small pre-done movies that I've done in before. So let's get to the meat of the talk, the backend. I chose in the beginning the Rocket framework because as a Python developer, my background is basically on Django and Flask. These are, especially Django is a very evolved tool, and you are basically spoiled because you have everything batteries included, and I wanted to try something that could mimic the quality of the framework I'm used to. So at the time when I started the project, Rocket was the most interesting between the available offer. So I just try that and see what happens. The main features, it's a simple backend. Basically, there is authentication there are a couple of endpoints that are authenticated via through an authentication token. This token is released every login, so there is a policy to trim tokens, renew them, let them expire, and so on. Then there is an admin interface, which is authenticated through cookies, and the CERT decrets that everyone that done a little bit of Rust probably knows, because it's really useful crate for serializing data and models. It really great tool to work with. So let's go through quickly on these two main tools that I used to. Basically, there is the web framework and the Diesel ORM. Okay, so how do you basically create a Rocket web backend? You have your endpoints, you mount them, then you attach a thread pool of database connections, and every time there is a new request, a new socket is picked from the pool and used to connect to the database. And then you have a couple of catchers for most common errors, 404s, 401s, 422, and whatever may encounter. Then you ignite the Rocket and it starts listening on your port behind your Nginx server, for example. The typical endpoint, here we see a summary of a typical endpoint, a very simple one. you define the endpoint, you define the content type, then you have the signature of the function that define all the request guards that Rocket gives you. In Rocket parlance, the request guards are middleware that are happen before the request reach the endpoint. So for example, in here we see the database connection and the authentication. That means that before you reach the endpoint, you have one socket from the database that taken from the thread pool. Then you have the authentication check, whether the token or the cookie. And then you get into the endpoint, you make your query, you find the user, and if there is an error, either you return the error, or if the query succeeds, you return the user to the client. This is a very simple example of endpoint. The diesel framework, of course, you expect migrations. So this is just an example of a couple of migrations that I have on the backend. This is, I think, pretty much familiar for whoever has worked with backends. And this is also the kind of tool that you expect from a web framework, I guess, which has an ORM. Let's see quickly how Diesel works, because it's another tool that I find very ergonomic to use. So we have basically the model is a structure that it's linked to a table. Inside the structure, you define all the fields that you have in your model, and you can add the validation to the model. This is very useful because when the endpoint, you receive data to manage this endpoint, with this validation provided by these crates here from Vincent Prouillet, you can really easily validate the data that is incoming, and really saves you a lot of time and a lot of boilerplate doing manually these things. And again, this is the kind of ergonomics that I expect working with a web framework. Let's move on. Let's see quickly how it works then. We have the model, we have the validation for each field. So we basically just have to create a new instance of our model. We run the validation, which is provided by the struct we defined earlier. And again, if everything works, we the query succeed and we do our insert or delete or whatever query we want. Otherwise, we raise an error. Again, this is a very basic example, but it should give an idea of how easy it is to work with these tools. Now, let's go to the fun part of working with Rust. So, as I mentioned before, I had a Raspberry Pi, which is an old model. The CPU is an ARM v6. It's not very much supported anymore, in my opinion. It was not easy to find instructions on how to compile, to cross-compile. The good news is that if you want cross-compile with Rust, it's very easy because you just have to add a target to the toolchain. So you basically just have to change target and automatically you can cross-compile to all the supported architectures. The tricky part is that it's not always so straightforward because, for example, in my case, I had to cross-compile the whole Rocket and Diesel crates. This means that all the dependencies should be cross-compiled also. And since I have an OpenSSL and the SQLite, in this case, dependencies, I could not easily cross-compile them out of the box. So what I did is find instructions on how to cross-compile on my workstation these libraries and then link them all together when cross-compiling the main project. Let's see quickly how it turns out that I could cross-compile on the ARM v6 architecture. So basically, first download a toolchain that is working for the ARM v6. This is not as trivial as expected because this CPU is the support is not so much working. So I tried a couple of them and they didn't work. When in the end I could find one that worked in all cases. Then you cross-compile the OpenSSL library, the SQLite library, you download the sources and you compile them, and you build your libraries that will be linked to the final project. Here you define where to look for the libraries that you just compiled, and in the end you just build your project giving some flags. And this is the easy part when you get to cross-compile. I find that it's a very interesting way to use Rust for cross-compiling. It's a great tool. So the other thing that it could be improved, but when you have to compile Rust, some of you may be already used to the not very fast compile times because all the dependencies. Let's see what I could manage to mitigate and reduce the waiting time for compiling. I did find some hints on what I could accomplish to reduce compile times. Nothing life-changing, but in the end something can be done and very effective. So the first thing that you can try to do is disable the link time optimizations for development builds. This is just a flag that you can put in your cargo-2ml file, so it's very easy to implement. Then, if you can split the project in submodules. In my case, this was not very practical because I had to refactor too much code and the price of refactoring was not worth the effort of the gaining that I would have had. So I just skipped this part. Other projects are more can be more easily splitted in modules. Or you can use SCCache, which is a tool provided by Mozilla that has added recently Rust support. This is very useful because all the dependencies that you build and compile for your project will be cached aside. If the dependency does not change, you're not going to rebuild the dependency. So you will, in the end, you will save a lot of time. Still, I had to update this slide a couple of times because the tool, the current version that you can install using Cargo is not working very well. But I contacted the GitHub repo, I opened an issue, and luckily the people from the project gave me answers very quickly. So in the end, if you just check out and compile SCCache from the master branch now, I mean, from 2 days ago, it will work very fine. So I strongly advise using this because it really saves a lot of time. Just to give you a rough number, to compile my project without using SCCache, it takes 40 seconds or something like that. Using SCCache, I do it in 15 seconds. So your mileage may vary, of course, but this is a pretty much good improvement. And now the deployment. Deployment on ARMv6, it's not an easy task. I tried using Docker, but it didn't work so very well on that architecture. I tried Balena.io. It's a service platform. It's a service that compiles your code on a virtualized ARMv6 or ARMv7 CPU and then deploy on your device. But at the time when I tried this service, the target for ARMv6 did not work, so I had to explore other ways to solve the problem. Now they have fixed this problem, so if you want to try, it should also work on ARMv6. Unluckily, yes, the really life-changing tool that I've discovered thanks to the Italian Rust Slack channel is cargo-deb. It's a very practical way to build your application and package that in a single file that you can easily deploy on your platform of choice. I think cargo-deb also supports other targets, not only deb files. I don't know, but you can output a deb file and deploy on a Debian or on Ubuntu distribution. But maybe there are other targets. I didn't investigate that. Still, the deployment is not fully automated as I expect because, for example, the migrations It's a little bit tricky because you need another crate, which is Diesel, the command line interface from Diesel. This crate needs the development libraries and headers for the backend database that you're using, either Postgres or MySQL or SQLite. And when you install this crate, you need these development packages. And maybe you don't want on your production server to download all the GCC toolchain to compile these crates. You might want to do this on your continuous delivery machine and then just deploy the final artifact. So I still have to work on how to fully automate the migrations. So let's go to the lessons learned. From this project. Rust, as many of you already know, if you have worked a little bit on with Rust, is the combination of strong typing and serialization libraries, in my opinion, is a really killer combo because it really saves you a lot of time and gives you a lot of confidence in your code. If you have to refactor either small things or big things, your project will not work anymore and you have precise indications on where you have to fix. And this is really an invaluable help when you're working with your code base. Still, it's a compiled language, so in my experience, it's not as easy to hack together quickly prototypes like you may be used in Python or other languages which have other features. But still, one thing that I've been thinking on is that although working in Rust seems to be slower than your usual workflow, in the end you will think that when your project compiles, you're already way ahead and you have much more trust in what you have done. So even if it takes more time, it saves you a lot of time after, and you may not immediately realize how much time you save when your project compiles. Developing on Nightly is not always easy because sometimes the builds break the libraries, and the libraries crates are not as fast to stay behind the Nightly compiler. Things have much more improved since a couple of months. For example, 6 months ago, it was, in my opinion, a little harder to update your project with Nightly. Still, talking about the Rust in production, if you speak to some Java developers, for example, and you tell them that in Rust you use the Nightly compiler, you may receive blank stares because, I mean, you're using a compiler that is updated every night. Another thing that I've been thinking of is Createit.io. This is a great tool to distribute packages, very easy to use, an invaluable tool, but still on the security side there are some things that should be worked on. For example, sometimes when you download a crate, this crate is locally compiled on your workstation, and sometimes you see there are dependencies from other crates, and sometimes dependencies from GitHub repos, forks. So the question is, what am I really downloading? Why this guy forked the crate to? What am I compiling on my machine? So there should be, I don't know how, but some kind of trust policy on the crates that you download, a chain of trust that could be established in order to give more trust on the tools, on the crates that you download. We know that bad things can happen, npm anyone, and so another thing is also that it's very easy to create a crate on Createit.io. So, for example, the other day I was distracted. I wanted to download and install Cargo Watch, which is a tool that auto-reloads your project as you change your code. And instead of writing cargo install cargo-watch, I have wrote cargo install watch, and I have downloaded something completely different from Createit.io. Luckily, it was just a simple create, which does nothing, but this create that I have downloaded could have been malicious, and it could mimic the work, how cargo watch work, and I could have not noticed that until, I don't know. So these kind of things. If you work with unit tests and the integration test, in my opinion, this is a very it's easy, it's well structured. You can have unit test in your code, you can have integration test in your test directory. This is a part of Rust that I like, and I find familiar coming from other languages. Some minor annoyances, because I'm really picky. I want 0 warnings in my code. So for example, I've noticed that in the integration tests, I have a common library of tests and then a couple of modules with tests. Since each test is compiled as a standalone binary, if you have in your library some functions that are not used in that module, you will receive a warning of unused function. So I don't want all these warnings, so my workaround was I asked for a suggestion on the Createit.io people, and they suggested to create inside the test directory another crate that will compile all the tests together. So you have 2 advantages. You save time on your compiles because tests are compiled once all together, and then you will not have all these annoying warnings that really are annoying. Cargo check still has a minor annoyance too about warnings, because when you run cargo check on your project, it will show errors and warnings. On the second run, without changing the code, the warnings are cached and you will not see them anymore. So this is an open issue and not solved. I just had to alias cargo check to touch a file inside the project in order to trick cargo check that there is something changed. But these are really small annoyances, nothing important. The continuous integration and delivery, looks fine on Rust, because working on the GitHub repos, you have access to Travis CI and Circle CI. They both have support for Rust. I only use Travis in this moment, but everything looks fine here. Deploying, as I mentioned before, is not easy. I need to solve this, for example, this migration thing. I've been suggested to use, for example, if you have a deb file, you can set targets on the deb post install to run migrations. I still have to figure it out, sorry, but it should work, because I don't want to compile anything on my production environment. So, is Rust suitable for web development? It depends. For a small project like this, it was an easy task to do, and so I would recommend that as a learning exercise without any problems. If I had to use a web framework for a production and a paid project, there are some things that are, in my opinion, not ready yet. The tools are there, but the time that it takes to deliver the features are a bit higher than you might expect for some features. For example, if I have a customer that now I have started a project and I have to write another backend. So the first thing that when you have a backend, a front-facing backend that interacts with users, is a login and a sign-up endpoint. If you're going to do that in Rust, it takes, in my experience, it takes more time than using other languages and tools. So I cannot sell a login and a sign up basic endpoint with the user administration done in Rust, because it would take too much time to do that. So, for example, other frameworks gives you the admin user interface out of the box. This is a really plus that we still don't have in current web frameworks in Rust. But for network applications, I really appreciate how you can write asynchronous application, very performant. And so I would definitely recommend for writing server-to-server components, microservices, and this kind of networking, of pure networking applications. So here we have a couple of just links for the backend if you want to have a look, and for the mobile application. And yes, basically that's it. I would like to just mention and thank all the support that I've received from the community, because this is another important thing that I had to underline. I asked everyone from the Italian Slack channel to the Diesel Gitter channel on IRC, on Discord. I basically bothered everyone with my trivial and not so trivial questions, and I have always received support and useful hints. And this is a really great resource when you are developing in Rust. What else? So thank you for listening this talk. I hope that I have give you some interest in web frameworks. I would like to remind that tomorrow there will be a specific workshop on web frameworks, not Rocket but Actix, Actix 1.0, which is a very, it's in my opinion, it's not so easy to learn as Rocket, but it promises better performance. First, because it's asynchronous, while Rocket is still synchronous, although they are starting to work on the asynchronous part while we are talking. And yes, Actix works on stable, so you don't have you have a easier way when you develop. You don't have to stay ahead and to the nightly compiler. And yes, that's it.
Okay.
Yeah.
Thanks a lot for the talk. Basically 2 short questions. One is, what pushed you, or have you considered other ways to build your system to stay unstable and not use nightly? And another question is, what performance did you get from running your application on Raspberry Pi?
Okay. The stable compiler, in my case, was not an option unless I wanted to move to Actix, for example, or other let's say HTTP crates that to build a web application. But my backend is with Django basically, so I wanted a full-fledged web framework. I want to do the less job and boilerplate possible. So the only choice at the time was Rocket, because Actix looked too esoteric. So Rocket only runs on nightly, sorry. So basically that's what an option. And the second question about performance, I don't have, it's a SQLite database, it's a coworking entrance system, so you don't really need the performances because you have a couple of calls during the day, and it's not. I don't have numbers and figures about performances because it's a very low working. It's a very. It's not a project that will run with many concurrent connections. So basically, in this case, it was not my concern. So I could also not. There are some things in the code that should be improved. Yes, but that's not my main concern in this moment.
So I guess as long as you don't have to wait 10 seconds for the door to open, it's fine.
Yes, correct, exactly. But
Thank you.
still, yes, as an anecdote, I can tell you that from the mobile application call to the door opening takes 2 seconds, something like that.
Cool, thanks.
Thank you. Before we finish, I want to show you also 2 small movies because yeah, I brought the and then yeah, just before your question, I brought the device I have at I have the Arduino board, but since it's very small, I cannot show you. So I will just show a couple of pre-made movies that I've done in these days.
Okay,
Please,
my question is about the cross-compilation environment. So, first of all, why did you actually need to cross-compile SQLite and OpenSSL? Aren't there packages for the Raspbian that runs on the Raspberry Pi? And the second question, which is sort of related, is when I do those kind of things, now I'm stabilizing on using a Docker-based cross-compilation environment, which is very handy because I do cross-compilation, but the cross-compilation environment is very fixed. I don't need to think about installing the cross-compiler or having the environment. Everything is integrated. In some way, it is a container that has both the Raspberry Pi sysroot, so that you actually have the installed packages there, so that you have the correct header files and libraries for linking and everything, and the cross-compiler that runs on the host. Everything is integrated. I would suggest maybe we'll talk about that.
Yes, having a look at that. I remember at the time I tried to use Docker as a platform to not having to install all the cross-compiler. And I didn't really manage to make it work, probably my fault because it was the first experiment with cross-compiling. So your suggestion could make much sense. But yeah, I couldn't manage to have either Docker on the Raspberry Pi or on my machine.
It's not simple. There is a Docker project that does it all. It's not simple because this project actually builds a Debian sysroot inside the machine. So this Debian sysroot is the ARM one, which means you have all the files you need for cross-compiling.
Yeah, I think
then you have the cross-compiler.
I think I tried what you mean. Someone from the Slack channel told me to install, I remember what package or toolchain, but when I cross-compile for this target, it automatically downloads a Docker image and compiles inside this image. I don't know if this is what you're talking about.
It's slightly different. You start from a Docker file, not from the cross-compile, but
okay.
We'll look at that.
Yeah, okay. Did I answer all your questions? Okay.
Hi. Hello.
Hi.
I have a question about the communication between the Arduino and the Raspberry Pi. So the network, and did you use the USB, the serial port, or just TCP, or how did you control the Arduino?
The programming happens with the USB connection. I just plug the Arduino to my workstation. I have the Arduino IDE, and it just talks through the simple serial port. And then I can deploy the blob compiled on my machine. And this is how I program the Arduino. And then the connection between the Arduino and the Raspberry Pi simply happens through the wireless LAN, because they both connect to the internal LAN. So there is an HTTP server listening on the Arduino, and I can reach that from the network, the internal network.
Thank you.
There is no magic.
One question. did you think about moving it to an RFID token so you don't have the issue with the local internet? Because you are in a local area, so you have the dynamic host protocol, so you have your internal LAN for your HTTP server, but the connection of the app to the internal host can be broken if the provider breaks down in the surrounding area?
That's a good question. That's what exactly happened this weekend. We have the cable internet down, so the mobile application is not connecting anymore to my Raspberry Pi. So we are, how do you solve this? We just thought that the Arduino could have some code to manage this case when internet is down, and open the door when you just ring the bell. But these are just tricks. I don't.
We're doing something. We're building power sockets, and we have the idea that everything should be decentralized. So we use different protocols. But besides that, the main thing is that we try to compile. There is via WebSocket, you can open an RFID connection within the JavaScript application and send a security token to your receiver, as long as there's an RFID receiver on the other side, and it's secure. So basically, you can just cheat it like that. And I was wondering, because there's two ways, because I think Apple is switching to Bluetooth right now. So we were wondering if you should go for Bluetooth and for RFID. And so I was wondering if you had some of those thoughts as well.
We thought about Bluetooth, but the RFID solution is also very interesting. We have a couple of RFID devices. And yes, basically either that or that one, or either that or the Bluetooth solution could be a viable alternative to the mobile application. Instead of signing up, register, and click a button, you just put your device in the nearby or the RFID. Yeah. That would be really interesting. Yes, we are exploring something like that, but still didn't figure out anything at the moment.
Okay, cool. Thank you.
So this is just a quick movie of how the circuit board works. As you can see, on the lower right part, there are 3 buttons. One is for the login. That's when the application connects to the Arduino. And then there is the doorbell ringer that triggers the switch to open the door. And then there is a logout button, which is a kind of a hack, because what happens when you log in, you can open the door as much as you want. So at some time we have to put some kind of delay, and after you got into the building, we have to cut you off. So you're not, the challenge token should be discarded, and we don't want, we basically want to open the door just once for call. So this is just the light that opens when you connect, and then you ring the bell. The node MCU receives the command, the switch opens the door, and then it locks you out. There's not, unfortunately, there's not much to see unless I brought from Germany a 2 tons door that opens. But I have another movie. Let's see if I can show you. Okay, it's a little bit stretched. Let's see if I can improve on that. No, I want full screen on the other. Okay, so this is just a demo that I've it's not 3D, it's just a bug. This is just a demo that I've done a couple of days ago, actually weeks ago. I wanted to do a new demo of the new system, but internet was down, so so basically this is the entrance of the coworking. I hope you can see it's a little bit stretched. The door normally is closed. I'm trying to break in, doesn't work. So this was the first the first prototype of the mobile application. You ring the bell. If you're not signed up, you sign up. You receive the token, and then you are logged in. Now you ring the bell, and when you receive the OK, you call the Raspberry Pi, and it opens the door. And that's it, basically. It's really nothing really incredible. It's not rocket science. It's just a switch on the doorbell. But it saves a lot of time when you are coding, and you don't have to go to the door and open for the people that enters. Okay, thank you for listening. Yes.